Idle GPUs cost enterprises money. Imagine your GPU is a high-performance race car, and inevitably it has to pull into the pit. Every second it's not on the track, it's falling behind in the race. The crew's efficiency affects its ability to get back in the race. Just like the pit crew, during inference, all the data center components, the networking, the storage, the memory, work together to keep the GPUs fed. Inference is where AI turns into value. And more than ever, inference ROI depends on system efficiency. Not just how many GPUs you deploy, but how smoothly the platform can deliver tokens at scale. What's really changing is the workload itself. Inference has moved beyond one-shot prompts to persistent conversations, assistants, and agents. Today, a single rack may be supporting thousands of sessions at the same time. Each of those sessions looks lightweight on its own, but together they create a growing working set, one the platform has to preserve to stay coherent and responsive. That working set lives in the KV cache, the model's working memory during inference. From here on, we'll simply call it context memory. As context memory grows, it can stretch beyond the memory tiers closest to the GPU. And when the platform has to fetch, move, or recompute that context, token generation slows, utilization drops, tail latency rises, and cost per token starts to climb. A common response is to lean on existing network storage resource in the data center, but active context is latency sensitive, and distances introduce contention. Longer network paths add variability, and even small delays can stall the pipeline. That's why the industry is starting to introduce a rack local context tier inside the pod. It's a meaningful architectural shift. A new storage tier right alongside compute, close enough for predictable access and large enough to scale across many concurrent sessions. You can think of it as a new layer in the memory hierarchy. G1 is GPU HBM, G2 is system memory, G3 is local SSDs, G4 is remote storage, and this new layer sits in between, a new G3.5 context storage tier. This context is created on the fly as the model runs, and it only matters while the conversation is active. It's reused across turns and sessions and then cleared out as workloads change. The goal is to keep the right context close without forcing it into distant storage paths. Once storage sits in the inference hot path, the priorities shift. Density and watts per terabyte shape how much context fit in a rack. Sustained quality of service and tail behavior shape whether GPUs stay busy. And endurance has to align with how much context is reused versus replaced. The payoff is efficiency, fewer stalls, higher concurrency at target latency, and better GPU utilization, which is where inference economics are ultimately won or lost. The takeaway is simple. Inference architecture is being redesigned around context efficiency, and storage optimizations will drive the next generation of inference infrastructure.